Area of regular polygons with trigonometry. Area, equilateral triangle. So first, to review, area of any triangle with base length b and height h is given by area is half times base times height. So any triangle, the formula is area equals half times base times height. Now, equilateral triangle has a different formula actually. To find their area based on the length of the side, because all three sides are equal, this is the area formula. So area is radical 3 over 4 times s squared. I know it's a weird formula, but that's how you find the area of equilateral. So another way of writing it is s squared radical 3 over 4. Just put this in the front here. So it's the same thing. You can write this way and this way. So this is the formula of equilateral triangle only. Every other triangle is half times base times height, but this one is radical 3 over 4 s squared. So it's a special formula for equilateral triangle when you try to find the area. So I'm going to actually show you how this area formula came about. So try to understand the equilateral triangle area formula. Let's see where the equilateral triangle formula really comes from using A equals half times base times height and special right triangle. So right here, let's say if I draw a line here, the area of a triangle is half times base times height, right? So area is half times base times height. Let's write that. So area will be half times, let's say this is S, because S, the side. So that's S, that's the base. The height will be S radical 3 over 2, because this right here will be S divided by 2, because this is equilateral. So if I draw a altitude, the height, it's going to be bisecting. So if this is S, this side will be S divided by 2, this side will be S divided by 2. In that case, this height will be S radical 3 over 2. Why? Equilateral has 60, 60, 60 angles, right? If I divide it into half, this height altitude divides 60 into half, bisects, then this is 30. 30, 90, 60 is a special triangle. So if this is S divided by 2, if this is S, then this will be S radical 3 divided by 2. You're going to put radical 3. You know where that came from? Previous unit. If you look at this special triangle, I'm going to make it bigger so I can show you. If you look at the unit right here, when you have 30, 60, 90 special triangle, if you have the leg, which was S for us, and then this was S, right? This is S radical 3. So this was S divided by 2. This was S. Then it's going to be S divided by 2 radical 3. So this is where it came from. The special 30, 60, 90 triangle. So go back to this. This is 30, 60, 90. So S divided by 2, then S over 2 radical 3. That's how you find this one. So if I apply that, the height will be S radical 3 squared over 2. If I plug this, the base, which is S divided by 2, times half times S, which is S divided by 2, right here, times this, that's S radical 3 over 2. That's S times S, S squared. Radical 3, 2 times 2, 4. That's how we came up with this area formula. So S squared radical 3 over 4, or radical 3 over 4S squared. But if you don't understand how this formula came about, you can just memorize this formula, or you just memorize and just use it. Okay? I was just trying to explain that this came from the 30, 60, 90 special triangle. Okay? Special right triangle. So anyway, when you have an equilateral triangle, this is the formula for the area. Okay? So we're going to find the area of an equilateral triangle with 8 inches sides. All you have to do is plug it in. Super easy. 8, 8, 8. They're all equal. That's why it's equilateral, right? So plug in 8 into this formula, S. So S squared is 8 squared, which is 64. Radical 3 over 4. 64 divided by 4 is 16. You just divide just the numbers. Radical 3. So that's the answer. Just put square inches because it says inches. All you have to do is plug it into this formula for area of an equilateral triangle. So this is the answer. Now, vocabulary. Radius. Radius goes from the center of the polygon to the vertex because it would be radius for a circumscribed circle. If I draw a circle around, that's going to be also the radius. So you can also call this radius here. We have another vocab, apothem. Can you say apothem? The height of a triangle between the center and the two consecutive vertices of a polygon. So right here, you see right here, if I actually draw a triangle, you can have triangles here, number of triangles, and the height of the center right here of this polygon to the right here is the height of this triangle between the center and the two consecutive vertices right here, two consecutive vertices. So here this vertex and this vertex, they're consecutive, the middle, right, and connects to the radius. That is called apothem. Apothem right here, this A. See that I wrote A there? This is apothem. It makes perpendicular line to this. So that's called apothem. So area of a regular polygon. The formula is area is half times apothem times perimeter. Okay? A regular polygon means all the lengths of each side is the same. So remember, regular means all the sides are the same. So basically, we're going to plug it into the formula, get the apothem, get the perimeter around the polygon, and plug it in, and we're going to find the area. So we're going to do that later on, okay? This angle right here, we call this an angle whose vertex is the center and whose sides are radii of the polygon. We call this central angle of a regular polygon. So for example, this right here, AGB, this right here is called central angle of this regular polygon. And then we have a hexagon here, six-sided polygon. In order to find this measurement, there is a formula for this. Central angle is 360 divided by n. So if you do 360 divided by 6, this will be, because this is six-sided hexagon, this will be 60. So the central angle is 60. You can divide 360 by the number of sides to find the measure of each central angle of the polygon. Why is this value helpful? Because you have SOHCAHTOA. You can use that. And also special right triangles. Please write these down. So we're going to find the area of this regular polygon. We're going to use area equals half apothem perimeter. So what you're going to do is, you see this 8.6, okay? You're going to use half times. So here's where it gets tricky. So you need to use special right triangle to find the ratio, to find the apothem. So this is what you need to do. This is a hexagon, right? So the angle in the central angle will be 360 divided by 6, which is 60. So I need you to draw and write 60 there. Okay? You need to find apothem in order to find the area of this regular polygon. So I just redrew over here. So let's draw this triangle. This triangle is this triangle. So if this is 60, if I draw apothem, which is the height of this triangle, that's going to be 30, 30, right? It bisects. That's going to be 30, 90, and 60 right triangle, right special triangle. So the ratio for that is, this is 8.6. If you cut it in half, it's 4.3. So I just need this height, correct? This height will be 4.3 radical 3. That is the ratio for 30, 60, 90, okay, leg. okay? Because this will be a leg if I look at this. So this apothem is 4.3 radical 3. So you need to plug in 4.3 radical 3 into A, okay? And then the perimeter of this regular polygon is 8.6 times 6 because there are 6 sides. So that's 51.6. If you put on the calculator 43 radical 3, you're going to get about 7.45. If you do, so you got to put this in the calculator, 4.3 radical 3. And then it's 7.45. You're going to do half times 7.45 times the perimeter, which is 51.6. So if I multiply these three, I get 192.21 square feet. So apothem is where it gets confusing because you need to use special 30, 60, 90 for this, or you have to use SOHCAHTOA if it's not 60, if it's not special right triangle. Special right triangles are 45, 45, 90, or 30, 60, 90, right? So we need to use that or SOHCAHTOA to find the apothem, all right? So let's copy this and we'll definitely do more practice on this. So take a look at this octagon. So first we're going to write the area formula. Area is half times apothem perimeter. And then we're going to find this apothem. We're going to use cosine because if this is a octagon, you can do 360 divided by 8, which gives me 45 angles. So the central angle was 45. Now, if I actually want this right here, I cut this 45 into half, which each one angle is 22.5, 22.5. Sorry. If I do cosine of 22.5, adjacent of our hypotenuse is 10, right? So I can use this way. Then I can write cosine of 22.5, this angle, is adjacent over hypotenuse over 10. Then if I put this in the calculator and if I solve for A, I get 9.24. So I put cosine 22.5 and times 10. Then I'm going to get 9.24. That is my apothem. So I use cosine for this. So in order to find this side, I'm going to use cosine again. If this is 45, then I'm going to do 180 minus 45 and divided by 2. That gives me these two angles, which is 67.5, 67.5. Then I'm going to use cosine of 67.5 to find this right here. Cosine of 67.5 is adjacent over hypotenuse. So adjacent, right, over hypotenuse right here. So that's x over 10. So the x is this right here. So if I do that, I get cosine 67.5 equals x over 10. Then I'm going to cross multiply. I put this on the calculator, multiply by 10, I get 3.83. If this is 3.83, I'm going to double it. 3.83 times 2 will be 7.66. So this is 7.66. And then I'm going to use that as one of the sides, and then if I want to find perimeter, is 7.66 times 8, which is 61.28. So basically, I use cosine for apothem, cosine to find this side, and then double it, and then I got the perimeter of 61.28. I know this is super confusing, so we will review and do this together in class. Just copy down the notes for now. And then so you can use it when we're doing the review in class. So write 61.28 for perimeter, write 9.24 for apothem, and then just put this in the calculator. Half times this will give me area of this regular polygon, which is 283.11 square meters. We're going to stop the video here, so we're going to do the next two problems on the paper in class so I can explain again. So please stop here and make sure you take good notes up to here. Do not worry, I'm going to explain and do those problems with you so you can have a better understanding.